So this video is going to be used to kind of review some basics about linear functions. Those of you who have been in my class know that I like to introduce linear functions by thinking about a tricycle race. And here's some fun pictures of what you might imagine for a tricycle race. To get started on this thing, we're going to look at these 7 different skills involving basic linear functions. I'm not going to look at all of them all in one video. I'm actually going to stop right about here and just introduce 2 of them, make a couple other videos, and to be able to kind of get through this whole thing. So we're going to look first at graphing points, and I've got this set up with a graph and a description about what's going on with Adam's tricycle race. So we got Adam on his tricycle, and after 4 seconds he's gone 8 feet. And so on this graph here, we're gonna kind of keep track of what Adam did. Down here we've got the time in seconds. Up here we've got the distance in feet. And so we're going to make a little mark right here to indicate that, oh, no, we're not. We're going to make it right here to indicate that Adam had gone, after 4 seconds, he'd gone 8 feet. And then we're also told that after 6 seconds, he'd gone 12 feet. So here's 6 seconds right here. We'll go up to 12 feet right there. And we'll say there's a picture of Adam's progress. Okay. Well, what we're doing is taking this information about Adam's progress, and we're representing it here on this graph. And the scales down here and up here tell us where to go. So we looked and said, all right, 4 seconds. That'd be out this way, 4 seconds. And then 8 feet would be up this way, 8 feet. So we went to the place where those two meet, right there. Same thing with 6 seconds and 12 seconds. We went out 6 and up 12. Okay, so we've got Adam's progress there. And we're going to leave that alone for just a bit. And we're going to look over here at Bob. Okay, we'll switch colors for writing. And Bob, after 2 seconds, he's gone 8 feet. Well, 2 seconds is right here, and he's gone 8 feet. Whoops, wrong color. And wrong place. Better drink some more coffee. 2 seconds, he's gone 8 feet. Okay, and after 6 seconds, he's gone 24 feet. So we'll go out here to 6 seconds, go up here to 24, and there he is, right there. Okay, so we're tracking this information on there, and oftentimes what we do when we put these points on the graph is we make a little set of parentheses, and we put both numbers in here. This is 6 and 24. Okay, and it's important to recognize what we're doing here. The first number is always how far we went to the right, and the second number is always how far we went up. Okay, so for Bob's other point over here, 2 and 8, we'll have a 2, comma, 8. So they're separated by commas. Always put them in parentheses, and so we've represented that point with those 2 numbers. We call them coordinates. Okay, an x coordinate and a y coordinate, because we oftentimes call this the x-axis and the y-axis. Okay, so I'm going to go back and put Adam's coordinates in there for these points. I've got 4, 8 right there, and I've got 6, 12 right there. Okay, so we got one more person here. Carol is kind of taking her time, you'll notice here. After 8 seconds, she's gone 6 feet. So 8 seconds out, 6 feet up. Whoops. Okay. 8 feet out, 6 feet up, right there. Okay. And after 12 seconds, she's gone 8 feet. So 12 seconds, 8 feet, right there. All right, so we call this graphing points because we're just taking the information that's written as text over here and we're putting it on the graph, and then we're using this notation, the two numbers separated by commas, the horizontal distance first and the vertical distance. We put them in parentheses and we call it a point. Okay. So what does the point 715 mean? Okay, if you're looking at somebody, somebody's gone 715, what does that mean? Well, the first number is this horizontal distance right here, so 7, be right about there. Okay, first number is horizontal distance, second number is vertical distance, so right there, there's 715. Okay, but what does it mean? Okay, well, we'll read the coordinates. After 7 seconds, this person has gone 15 feet. Okay, so what if I had the point 612? Okay. After 6 seconds, they've gone 12 feet. Okay. Now, this wouldn't make much sense for a tricycle race, but what if we had the point 12, -1? Wait, 12, -1. Well, 12 is right here, 12 seconds. -1? It looks like somehow they decided to go backwards. Okay? So the first number tells you how far to go left or right, and the second number tells you how far to go up and down. What does it mean left or right? Well, you couldn't really do this, but if you had the point -3, 7, somehow back in time 3 seconds, they were at 7 feet. I can't even get it on the graph here. We'll do that later. Okay. So we're just talking about the meaning of these points here. So in general, what we're doing is simply graphing points, locating them on the graph here. And so we're going to use that skill here in a couple different places. So I'm going to put point A at 5, 6. Okay, again, the first number tells you how far to go left and right. Second number tells you how far to go up or down. So we'll go to 5, 2, 4, 5, 6. 2, 4, 6. I'm going to label that point A. Okay. Point B says 7, 0. Well, the 7, that's easy. It just goes 7 this way. 2, 4, 6, 7. What does the 0 mean? Well, it means don't go up, don't go down. Stay right there. Okay. Point C says go 4 to the right, and then the -3 means go 3 down. So we'll go 4 to the right and 3 down and put point C right there. Okay. How about point D? Well, the first number is negative, so instead of going to the right 6, we're going to go to the left 6. 2, 4, 6. Okay, and then 2 means go up 2. So here is point D. Okay. And then I'm going to ask you, what are the coordinates for point E and for point F? Yep. So let's look at them here. So this point is 2, 4, 6 to the right and 4 down. So here's 6 to the right there, and 4 down would be make it negative. Okay. And point F. Well, you started here and you go 2, 4, 6, 7 to the left. So 7 left, and then 2, 4, 5 up. So -7, 5. So you'll want to practice that some more. There's plenty of opportunities to do that. We can find a Delta Math assignment for you. You can review previous work you've done or do some other practice online. So the next topic was this. How about if I write a linear function for this? And of course, that sounds pretty scary. As soon as you see words that are unfamiliar to you, linear functions can be kind of strange sounding. Linear just means we're talking about lines here. Okay? And a function, we'll get more into this later, but a function basically is a recipe. Okay, so I'm going to look back at Adam's information here. I'm going to put it back on the graph. 4, 8 right here. Okay, and 6, 12 was right here. Okay, and I'd like to be able to write a description of Adam's progress during his race. Well, all I have is this information, but here's what I'm thinking. He might have started at the starting line right here when the race first started, and just looking at the pattern, it looks like he would have gone to right there and maybe right here and right there. So I'm looking at his progress across the graph, or across the race here, and it looks like in the first 2 seconds he went 4 feet, in the next 2 seconds he went another 4 feet, and in the next 2 seconds he went another 4 feet. So it looks like he's going 4 feet every second. Okay, and so I'm going to write that 4 feet per second. Okay, and he started at the starting line. So it'd be nice to be able to write some kind of a description about the whole event here, the whole progress. And here's what I'm noticing. The amount of time he spent, if you multiply it by 4, you get, nope, if you multiply it by 2, wow. Okay, rather than starting the whole video over, I'm just going to point out I screwed up. He actually didn't go 4 feet every second, and some of you probably caught that right away. He went 2 feet every second, because in 2 seconds he went 4 feet. 2 seconds went 4 more feet. So that means, yeah, 2 feet every second. So I screwed that one up. So he's going 2 feet every second. And so if you take the number of seconds that he's been going and you multiply it by 2, you get how far he's gone. Here's an example. If you went 8 seconds, then he's gone 16 feet. 8 times 2 is 16. If he's gone 10 seconds, 10 times 2 is 20. So here's what I can do. I can take the number of seconds and multiply it by 2, and I get the distance. Okay, so I'm going to write that a little bit more compressed. I'm going to say distance equals 2t. I'll use t for time in seconds. And so that makes a real nice way to write this this description here. The distance is just twice the number of seconds. And sometimes you'll see this, y equals 2x, because again, this is oftentimes called the x-axis and the y-axis. So if I'm looking at Adam's progress here, he's going 2 feet every second, and so I can just take the number of seconds, multiply it by 2, and get his distance. Well, so I'm going to write that over here. D equals 2s. I'm going to write that in blue for Adam's. D equals 2s. Well, what about Bob? Okay, there's an old movie called that. So 2 seconds, 8 feet. 6 seconds, 24 feet. If he started here at 0, 0, then let's take a look at what he's doing. Apparently, maybe after 1 second he'd gone 4, 2 seconds, 8, 3 seconds, 12. Hey, I'm noticing something here. It looks like he's going 4 feet every second. Okay, and so it looks like, because he's going 4 feet every second, I could take the number of seconds, t, multiply it by 4, and I'd get Bob's distance. Okay, so I can write this equation for Bob's progress. How about Carol? Okay, well, Carol, after 8 seconds, had gone 6 feet, and after 12 seconds had gone 8 feet. Here's the deal. If I track Carol's progress back to here, she didn't start at the starting line. Okay, so here's what I noticed. After 4 seconds, she'd gone 2 feet, or after 2 seconds, had gone 1 feet. She's only going half a foot per second. Okay, and she started at 2 feet. I'll put t there. There's her function. So I'm almost out of time. I can only record for 15 minutes. So I'm going to pause there, and we'll ask some more questions about this later on.